up, Hacksters? I'm here at Faire, New York, and I am checking out the Magnitude.io booth. This is a group that's doing Cubesats for like regular, everyday people, and it's super cool. So I'm going to try and get a quick interview with Ted Tagami, who's like the ringleader here.
Have you guys ever thought about putting something in space? Would you like to?
Yeah.
Oh, there you go, good. So this pavilion right here actually connects to the International Space Station. We have a lot of different experiences here. Some things we do are not necessarily getting all the way up into orbit, but we do grow plants in space. We do genomics research in space. We have microgravity robots that float around with little thrusters that are based on carbon dioxide sensors that go in space. All of this is actually available to students like you guys through the Center for Advancement of Science in Space. It's actually a nonprofit that's supported by NASA to get outreach so you guys can learn about cool things. One thing that I have here is a simulated satellite. It's not a real satellite, and the volume of what you normally think of is about the size of a soda can. And this actually originally came out of Stanford. Some Stanford students were building a real satellite, but it was so difficult that they weren't completing it in time. They were graduating from school and getting a little disappointed because they were watching their friends finish the satellite and launch it. So Professor Bob Twiggs, this is in the late 90s, probably before you guys were born, he said, "Can you put a satellite in my soda can?" They're like, "What?" They go, "Yeah, do that. It's not going to be a real satellite, but we can do a lot of the same things that you'd expect to do if you're going to build a real satellite." And so they built this. This particular one is based on an Arduino Uno microcontroller, and this little shield here measures the world around you. So it might measure things like the pressure of the air, or temperature and relative humidity, how much moisture is in the air, or how fast it's moving through space, acceleration across its different axes, or magnetic fields. It might measure light. I have breakouts, where we can add other sensors like carbon dioxide or particulates. And we put this in there and we learn about these different phenomena in science, and then we put them in big rockets like this red rocket right here. That little red rocket goes up about 2 miles. And at 2 miles, this CanSat gets ejected. And as it's hanging up in the sky and floating down, that's about equivalent as if an actual satellite had gone from the horizon to the horizon. So these Stanford University students and now some middle school students, I even have some students in elementary school doing the same thing these Stanford students have done. And so they're learning about satellites.
Those satellites, is there actually some of these in space right now?
Not the CanSats, but here's what's amazing. That Stanford professor, Professor Twiggs, about a year and a half later, started thinking about maybe he could actually make small satellites and put them into space. So before this, it's real rocket science, right? You have to know exactly how much your payload's going to weigh, and your rocket fuel's got to have the right balance. And if it's not, rocket's not going to do the right thing. So they were literally launching water and sand into space.
Wow. We watched this movie called Geothermal, and then around the Earth there was like this huge web around the Earth that had like little satellites around the Earth. It was like a web that connected all around the Earth.
Well, that's amazing. There are actually thousands of satellites in orbit right now, and they worry about orbital debris because if the satellites smash into each other, it makes many more debris components. But the Stanford professor, he started thinking about what he might be able to do to, instead of launching water and sand into space, of launching little satellites. So they came up with the modern satellite is just this big. It's called a Cubesat. And if you think about being on the freeway, you might see a big truck, like a 40-foot container on the back of a truck, or you might see it on trains, or sometimes you see them on ships. They call that intermodal transportation. You can fill up a container like that anywhere in the world and send it anywhere else in the world for just a few $1,000s. It's really pretty amazing. That's a 4-inch cube. That's the new modern intermodal transportation for space. This happens to not be a satellite. This is a cube lab based on the same form factor. So if you load up something like this with experiments, you can put it on a rocket like a SpaceX rocket. They will take me up to space and it will stall me on the space station, and I can run experiments. So what we've done here is we actually do that. It's very similar, except it's a 2U. It's twice as big. In space, this looks like just like this guy. It's an aluminum box with some fans on it. But on Earth, I got this in your classroom. And what we're doing is we're actually growing plants here on Earth, where we send their sister plants as little seeds up into space, and we're thinking about what life does if there isn't any gravity. We send them home again, and all the while those are growing, you're looking at your plants here on Earth. And I call it an internet of plants because I connect schools all around the country. And you can see what other schools are doing also. You can adjust the lights. If you want a different wavelength of light, maybe you want to try purple light instead of blue or green, you can see how that might affect the plant. It measures carbon dioxide, measures temperature and humidity. and of course the level of light as well. It just runs on a Raspberry Pi. So it's a live telemetry right to the iPad. And this is for the XB radios if you want to do a breakout for long range. So I can put this in the smaller airframe rockets now, and I can launch these from the school grounds instead of trying to get FAA clearance for the big rockets.
Yeah.
So just trying to make it more accessible.